Hello everyone, and welcome back to another video. And in this one, we're going to be talking about some of the worst lines of code that you could ever write in the real world. I still like making basketball related content on this channel, but I mainly get clips from my PS4, which, as you can see, isn't exactly functioning right now.
Work!
So until then, I'm going to be banging out these tech and coding videos, which I love doing anyway, so it's not really that much of a burden or a hassle. As I said before, in this video, we're going to go over a few examples of code that you could write in the workplace that could be potentially damaging for any number of reasons. And to see them all, make sure you watch to the end of this video. Oh yeah, and don't forget to like and subscribe for more cool content. Thanks. So in this first example we have here, we have these two variables, or better yet, constants. That's the const keyword in JavaScript. And they both represent date objects, which, as you can see here, that's the year 2019 and July 14th for today, and tomorrow is July 15th. And starting from line 5, if it's today, we want to run some code, else if it's tomorrow, run some other code. Take a few seconds to see if you could spot the issue here, keeping in mind that if this is a real program that you want to run in the real world for some program or application that you have. Well, the issue here is obviously with the date in mind. Sure, today right now is July 14th, or maybe whatever day you're watching this video, but it's not always going to be this date. And because this is a constant, this code is only viable for one day of running. So instead of hard coding this value, July 14th, 2019, better yet to use a built-in function of the date class, like today, because today won't always be that day. And for tomorrow, I guess you do today plus 24 hours or whatever suits your time needs. Alright, that was an easy example, so let's move on to something a little more difficult. So I have these 5 variables here, A, B, C, D. I'm going to add some more. These are all variables used for a specific program. See if you can spot the issue with how I'm declaring these variables as I'm creating them. And no, there's nothing wrong with me declaring all these variables on one line, even if it is a little messy. This is perfectly legal coding and should work in most languages. So the problem here is the variable naming. If I want to create a program using these variables, I'm going to very quickly forget what value A is or what value Q is. And the same goes, if not more, for any other person that wants to look at the code that I've written. Bad variable naming can take many forms, such as calling something, be careful with this. Yeah, I know that variable is important, but why should I be careful with this? And calling something secret value is a little better, but still, it doesn't exactly say what kind of secret value it is. Is it a secret password? Is it a secret user ID? Is it the secret to the universe? Like, it's still a little bit too ambiguous for general use. So what's a good variable name? I guess it really depends on the scope of your application, but in general, you should have some minimum standards, something like customer ID. That's a variable that if I'm someone that hasn't written your code and I come and look at it, oh, this is representing the ID of some customer. Enough information for me to actually know what you're thinking. This might not seem like it's that important, but whether you're working at a tech company or just by yourself on some clunky project, naming your variables appropriately is super important, and not doing so can set you up for hours of backtracking and just scratching your head figuring out what were you thinking. The first 2 examples are pretty harmless, but now we might just start ramping it up here. In this example, it's a simple for loop that runs 10 times, and during each execution of the loop, this sleep function is called. So if we're calling sleep 10 times in a for loop, what do you think is the issue here? This might be a little bit harder to conceptualize, but just take your best guess. Alright, so in general, it's weird to have your program stop arbitrarily for any reason when the program's not finished. It's pretty bad design. But when you want to stop your program for a total of 60 seconds, a whole minute, something's really going on wrong here. What if this program was powering a web page? If you want the program to sleep for a whole minute, that means that when a user goes on your website, they can't do anything. And if you're like me, if I'm clicking a button and it's not responding in 3 seconds, I'm probably leaving that page. This code was probably written because there's some other execution going on in the program that needs to get done for whatever reason. So this code was written to ensure that the program doesn't do anything else until it's run. Not a bad idea, completely understandable, but still very, very bad. There's no direct way to relieve the situation, but it starts with better code design. So we've got 2 more examples left, and this one involves a bit of mental work. These 2 statements are both using logical operators to compute some value. However, there's an issue with both of them, a big one. See if you can spot it. Okay, so if we look at the first statement, let's try to break down what's going on here. This is saying if x or x and y, then return some value. But something's redundant here, and it's the presence of x. If you're looking for x in both cases, then there's no need for the first statement because the second statement, if true, guarantees that x is present. So we can just break this down and just remove the first case and call it if x and y. Now for the second statement, even though it's a bit longer, it's not that much more difficult. Here we're checking if a and b, or if not a and b, or if a and not b, then return some value. It seems the author of this code is pretty much intending to write if a or b is present, and that's a whole lot more simpler than all those statements above. If you've watched up to this point in the video, thanks for sticking around for the final example. Don't forget to like the video if you haven't, and in the comments, let me know some of the worst code that you've ever seen, even if you've written it yourself. So right here, we're looking at a real world example of most likely some of the most dangerous code you could ever write. Here, we're looking at a function that's serving as a password encryptor. Since the main objective of encryption is to protect your password, can you spot the very obvious problem that's present in this code? This shouldn't even take long. The fact that in this function, all that's happening to the password is it's being reversed is so irresponsible and dangerous that it's not even worth a full explanation. There's code like this in the real world that take your password that you save to an account on a website and just store it on a server in plain text and in plain view for any hacker that wants to just take over that database and just take over your account. This happens very often. Reversing a password isn't enough to secure a password for real. There should be a lot more complicated algorithms and hashing and salting and all those cool buzzwords to at least make it a little more difficult for a hacker to break in. So there you have it. These are some of the examples of the worst lines of code that you could write. And of course, worst is subjective. Maybe you thought most of these were pretty harmless and probably not that bad, but in the real world, there are real life consequences, sometimes more damaging than others, by being lazy or being a bit short-sighted in how you design your code. And I just wanted to show you some of the examples. But anyway, if you watched to the end of this video, thank you so much. Don't forget to like, comment, and subscribe for more cool content, and get ready for the next video because it's gonna be a good one. Thanks for watching. Turn on